All right, seventh grade. Today we're going to review lesson 2 of our chapter 9 that we started last Friday. A lot of prime or composite number work and then prime factorizations, factor trees, right? Now remember, when you're deciding, just a quick review of some of these problems, and we'll do a few right out of your work. When you're deciding if something is prime or composite, you have to ask yourself, remember, if a number is prime if it only has two factors. In other words, 1 and itself. Remember, factors are numbers that can multiply together to get a bigger number. Composite has more than two factors. Okay? So basically, if you can think of any multiplication facts that equal that number, then it's composite. Okay, so like 63. Can you think of any multiplication facts that equal 63 besides 1 times 63? I can. 9 times 7, right? So that one has more than two factors, so it's composite. 67, again, if you're not sure if it is prime or composite, first think, is it even? Even numbers other than 2 are always composite because they can always be divided or by 2, or you can always multiply 2 times something to get them, right? Now this is an odd number. Can you try dividing it by 3? That's always a good thing to try because 3 is one that sometimes is a little tricky. 67, if I try divided by 3, it doesn't work, right? 2 times 3 is 6, and then 2 times 3 is 6, and I have a remainder, so that doesn't work. But so this one would be a prime one. There's no math facts that can multiply together to get it. But look at this one. Ones like this, I bet you in your mind you're thinking, oh, that's prime. But try dividing it by 3. It actually works. 4 times 3 is 12, right? Bring down a 3. 1 times 3 is 3. So 41 times 3 equals 123. So that one's actually composite, even though maybe your brain wanted to say prime at first, okay? So if you're not sure, try dividing. Ask yourself if it's even. If it's even, then it's a composite number, other than the number 2, right? That's a prime number. Or if it's not even, try dividing it by 3. Sometimes that can be a tricky one. Some of the multiples of 3 are kind of tricky or look like prime numbers at first. Then you're going to be asked to write the prime factorization of some numbers. Remember, that's a fancy way of saying they want you to do a factor tree. Sometimes the numbers are kind of big, like this one, and you may not know how to start. Well, there are some clues, right? If it ends in 5, you know it can be divided by 5. If it's an even number, you know you can divide it by 2. And so sometimes you might have to go off to the side and say, okay, what times 5 is 95? And do a little dividing here. And notice 19 times 5 is 45, and is 95, excuse me. And so I'm going to put 19 times 5. And guess what? That's as low as we can go. Can't break down 5 anymore. That's a prime number, and 19 is a prime number. So, and then remember to write them in order with a dot between for multiplication, and there's our prime factorization of that number, right? And then they're going to have you factor each monomial. Remember, monomials are these chunks of numbers and variables, or sometimes just a variable, or sometimes just a number. So what you want to do, remember, is grab that whole number and make a factor tree of it. Notice I'm done already. That's all you can do with 49. And then split these pieces up. So you're going to write it like this. C times C, and there it is. Okay, but remember, if there's a negative one, watch out. Remember, you should have a negative 1 in your factoring. So let's just ignore that negative for a second. 81 is 9 times 9, right? 3 times 3, those are prime numbers, and 3 times 3. Okay, and so I'm going to put my numbers in order, 3 times 3 times 3 times 3. But I'm going to add a negative 1 to the beginning because it's a negative number. Don't forget that today. Then we have 2 H's and 3 C's. There we go, so that was a longer one. All right, let's do a couple problems out of our work together today. You guys have just the odds today. Let's determine if some of these numbers are prime or composite. How about 41? Is that prime or composite? Can you think of any math facts that multiply together to equal 41? I can't. That's a prime number for sure. Okay, let's do one more. How about 39? Okay, can you think of any math facts that equal 39? I don't really have any multiplying facts right in my head that do. It's not an even number, but don't forget to try dividing it by 3. Does that work? In this situation, it does. 13 times 3 is 39, which means it has more than two factors, so it's composite. Okay, so be careful. Test it out if you're not sure. All right, then 13 through 21, they want you to do the prime factorization. So remember, that means factor tree. Let's do one of the bigger ones. How about 65? That's one of the bigger ones. You might have to do this on a separate sheet of paper because there's not a ton of room on this page. But 65, notice 65 ends in 5. So that would probably be a good thing to check out. What times 5 is 65? You can do some quick division to find out. 13 times 5 is 65. And hey, guess what? Those are both prime numbers. So we're done. Don't forget to put them in order and write them like that. Okay, so that's one of those middle ones for you. Then at the end, they want you to factor some monomials. Let's do one of the tricky ones. Don't forget on this one to have a -1. I want you to do that one because that's the only negative one. How about what if we do 29? That's one of the bigger ones. So remember to grab your whole number and make a factor tree. 9 and 5, that's a prime number. 3 and 3, those are both prime numbers. So let's write it in order now. So we've got 3 times 3 times 5 times 2 j's times a k. There we are. So I'll let you finish the rest on your own, but hopefully that gets you off to a good start again. Don't be afraid to contact me if you get stuck or have any trouble, but I think this went really well on Friday, so I think today will go really well too. Have a good day, guys.